Okay, second subtopic, which is on uniformly accelerated motion. So in this subtopic, you just have to be able to derive and apply the equations of motion with uniform acceleration. Okay, so in this case, all the acceleration is uniform lah. Okay, so let's derive this four kinematics equation. Okay, so there's four kinematics equation. You have to be able to derive them. Okay, so this equation is obtained from the definition of average acceleration, which is uniform acceleration, which is given by v minus u divided by the time. Okay, so from here you will then just get v equal to u plus kenapa plus macam tu, plus at. So that is your first equation, where u is equal to the initial velocity, v is the final velocity, a is the constant ataupun uniform acceleration, and t is time lah. Okay, and then from this first equation, the velocity against time graph is shown here. Okay, so this is the velocity against time graph. So the displacement after time, we can this shaded area under the graph, which is the area of the trapezium, we can actually determine the displacement lah. So it is from the shaded area under the graph of velocity against time, which is the area of trapezium lah. Okay, so the area of trapezium is equal to half u plus v times dengan t. Okay, so that is how you obtain the second equation. Okay, and then after that we can then substitute equation 1 into equation 2. Okay, so you will get s equal to half u plus a t. Okay, so from here we just rearrange it. You will get ut plus half at square. Okay, boleh. That is how you obtain the third equation. And then lastly, we can get an expression from equation 1. We can get an expression for t, which is v minus u divided by a. So we then substitute this t into equation 2. Okay, so equation 2 is s equal to half why am I confused? Oh, okay, u plus v, t is equal to v minus u over a lah. Okay, so rearrange this. You will get v plus u, v minus u divide by 2a. Okay, so from here you will get 2as v square minus u square. So rearrange that. You will get v square equal to u square plus 2as. Right, so that is your fourth equation. Okay, then, and that is how you derive in order to obtain this and this and this equations. Okay, example 3. A plane on a runway at velocity of 50 meters per second decelerates at a constant rate. The plane travels 1 kilometer before it stops. So we have to calculate the deceleration of the plane and the time taken for the plane to stop. Okay, so let me try to draw an aeroplane. Boleh lah tu. So this is the aeroplane, and then we have like that. So the plane travels 1 kilometer before it stops, so we can say that this is the 1 kilometer, and then the plane will then stop. Okay. Okay, so that is the displacement is 1 kilometer, which is 1000 meter lah. Right, so this initial velocity is 50 meter per second, and it will then stop, so that is equal to 0. So we have to find the deceleration. So what do we have? We have the value of s, we have the value of u and v. So what formula that we can use, the formula that we can use is the fourth equation, because we do not have the time, so we can't really use all three of this. The only equation that we can use is the fourth equation, because we have v, u, and s, and we are looking for the acceleration. Okay, so if you are confused on how do I know which equation to use, is you can just list down the information, the equation, so that you are able to see what information you have based on this equation lah. Okay, so we have u plus vt, we have s, ut plus half at square, and then we have v square u square plus 2as. Okay, so basically from this statement here, the only thing that we have is u, v, and s. So we don't actually have the value of time. So all three of this we cannot use lah. Jadi kita boleh guna yang ini saja. Right, so we use that. So v square u square plus 2as. So v is 0, u is 50, a is what we are looking for, displacement is 1000 meter. So we'll then get the deceleration to be 1.25 meter per second square. Okay, so why is it negative? Because it is decelerating. Okay, next we have to calculate the time taken for the plane to stop. Now kita perlu cari t. So we have a, we already have a, we have u, we have v, and we have s. So which equation that we need to use in order for us to calculate t? So we can use ini, ataupun ini. Tapi yang paling simple ini lah kan. So we can just directly use v equal to u plus at. Okay, so this is 0, 50 plus negative 1.25 t. So t is then equal to 40 seconds. Okay, so please so you can either use this ataupun equation yang inilah. Ini pun boleh je. Yeah, itu pun boleh. Alright, so that is on example number 3. Number 4 pula. Number 4, we are looking for the Ranger. Let me just find the solution, okay? Okay, so now, example 4. A park ranger driving on a backcountry road suddenly sees a deer frozen in his headlights. The ranger, who is driving at 11.4 meter per second, immediately applies the brake and slows with an acceleration of 3.8 meter per second. Okay, so it slows down with an it's an acceleration, not velocity. So again, I have to correct this. This is 3.8 meter per second square. Okay, so if the deer is 20 meter from the ranger's vehicle when the brakes are applied, how close does the ranger come to hitting the deer? Okay, so for this one, let me just draw. So this is the car, and then the distance, we have to find the distance where it stops just right before the deer. Okay, so this is the distance that we are looking for, and then we know that the initial velocity of the car is 11.4 meter per second. And then it tells us about the acceleration as well. Since it slows down, so it is negative 3.8 meter per second square. Okay, and how close does the ranger come to hitting the deer? So the velocity at that point, final velocity at that point, is equal to 0 lah. Okay, so from here we are looking for the distance. So the deer is 20 meter dulu. So the deer awal-awal dia 20 meter. So after this we are looking for this value of S dulu, which is the distance from the ranger initial point up till the final point, just right before it stops. Okay, so we can use the equation v square u square plus 2as because we are looking for s, the distance. Okay, so that is 0 square, no, square, just 0, 11.4, negative 3.8 s. So the displacement is equal to 17.1 meter. Okay, so that the distance between the stopped vehicle and deer, which is x, is equal to 20 minus 17.1. Okay, so the distance between the stopped vehicle and the deer is equal to 2.9 meter. Okay, so why is it 20 minus 17.1? Is because awal-awal the deer is 20 meter from the ranger vehicle. Okay, so the ranger vehicle until the deer is 20 meter. Dia cakap dia sempat tekan brake, and then dia cakap berapa dekat the car sampai dengan to deer. Okay, maksudnya dia tidak langgar lah to the deer. The deer is still there. So the question is implying that the vehicle stops just right before the deer. So itulah the distance yang we have to find. Okay, that's why we just minus 20 minus with the distance 17.1 yang we obtained tadi. Okay, so next question, how much time is needed for the ranger's vehicle to stop? So the time needed to stop, we can just directly use VU plus 80. So that is gonna be equal to negative 3.80. So that is gonna be equal to 3 seconds. Okay, so 3 seconds is needed for the ranger's vehicle to stop lah. Alright, so that is on example 3 and 4.